My name is Micah Dowd, and I'll be showing you the potential for the TGF-beta1 SMAD signaling pathway as a target for drugs to alleviate the formation of scars in dermal tissue. To begin, here is a summary of dermal wound healing in 4 major steps without any external factors and a focus on the TGF-beta1 SMAD pathway. Hemostasis involves blood clotting due to platelets and clotting factors. Inflammation involves the activation of the innate immune system, which triggers release of cytokines such as TGF-beta1. TGF-beta1 binds to TGF-beta type 1 receptors embedded in fibroblast membranes that lead to formation of a kinase receptor complex with a type 2 receptor, phosphorylation the type 1 receptor. Additionally, type 3 receptors act as co-receptors to SMAD2 binding and phosphorylation. The phosphorylated SMAD2 binds to SMAD4 to form a SMAD complex, which is a transcription factor for collagen 3 production, one of the key components of the ECM. When a suitable ECM is finished, remodeling can commence, with epithelial cells dispersing to fill the wound, and transformed myofibroblasts will convert collagen 3 to collagen 1. In pathological scenarios where the wound is too wide and isn't closed via stitches or other means, the ECM will be more abundant, leading to the overproduction of collagen and microvasculature into the wound that is packed differently from the rest of the skin, leading to the discoloration and bump that hypertrophic and keloid scars are recognized by. An experiment was conducted in rabbits' ears to test the efficacy of local paclitaxel injections on preventing hypertrophic scar formation. The results were an overall decrease in scar size compared to controls. Paclitaxel's mechanism of action is to stabilize microtubules, which can bind to SMAD2 or SMAD4 to inhibit the formation of phosphorylated functional SMAD complexes. The newly formed complex is unable to phosphorylate and will not enter the nuclear membrane for SMAD-regulated transcription, inhibiting collagen production. The current treatments to avoid excessive scar tissue either focus on minimizing the inflammatory period to lower the number of fibroblasts activated, or occur after proliferation to eliminate excess collagen, myofibroblasts, and microvasculature. Laser therapy is used during the proliferative or remodeling phase to denature collagen, induce apoptosis in activated myofibroblasts, and break down excess vasculature. Stitches to reduce the volume of the wound show improvements to the width of hypertrophic scars, and botulinum toxin, commonly known as Botox, has been double-blind tested to show an effective improvement of line scar formation. Botox has been widely used in scar prevention since the year 2000 and has shown minimal side effects, making it a very reliable medicine for this purpose. Paclitaxel trials for scar prevention in humans is difficult to find, which greatly limits the ability to assess it in greater depth compared to other injected pharmaceuticals, such as Botox, which is used to achieve the same goal in different ways. Disadvantages of paclitaxel include the limit of being a preventative agent, meaning that unlike laser therapy, it cannot be used after the proliferative period. And unlike paclitaxel for cancer treatment, it cannot be taken orally, requiring exclusively local injections for best function. Advantages of paclitaxel include that it is already a circulating drug, meaning that it is readily available, and its very lipophilic nature allows it to cross cell membranes very easily for better efficacy. To conclude, further trials need to be conducted to fully assess the efficacy of paclitaxel, which would otherwise make it a good competitor for Botox, only as a TGF-beta1 SMAD pathway targeting drug.